Desertification is a major global environmental problem. The harm of desertification lies in the discrete, flying sand with wind, which cannot retain water and nutrients either. Long-term effort have been made to control desertification, but they did not originate from the perspective of changing the discrete nature of sand. A group of experts specializing in mechanics from Chongqing JiaotongUniversity put forward a new method called desert soilization. They constrained the surface layer of desert sand together by mechanical means to form soil, which has good agglomeration and water-retaining capacity and is favorable for plant growth. Soilization has been successfully applied in different landforms and climates, with the total soilized area reaching 1,130 hectares. They discovered that soil has unique mechanical properties. It exists in two mechanical states. It is mud when wet, a rheological state, and a mass when dry, a solid state. The mechanical properties of soil endow it with two ecomechanical attributes, self-repair and self-regulation. The way of turning sand into soil is realized by adding a special constraining material to sand, which is in essence a change of the mechanical states of a granular material. The constraining material becomes an adhesive and cohesive solution after absorbing water. Then, each sand granule is surrounded by a sticky coating of the solution, which produces a miraculous omni-directional integrative constraint, ODI constraint. The ODI constraint is characterized by omnidirectionality and recoverability. The ODI constraint between any two granules is lost when they lose contact, but it forms again when recontact occurs between them. The sand with ODI constraint exists in a rheological state. When water evaporates, the ODI constraint turns into a fixed constraint, and the constrained sand turns into a solid state. Because the adhesive and cohesive solution is retained among the sand granules, the sand-turned soil exhibits strong capacity to retain water and nutrients. Desert soilization can be applied on a large scale in an efficient mechanized way. Generally, the surface layer of desert sand, 15 to 25 centimeters in thickness, is soilized. Desert soilization has the following characteristics: rapid ecological recovery, strong water-saving capacity, high yield and rich biomass, rapid growth of microorganisms, environmental-friendly constraining material and soilized sand, cost-effectiveness with potential economic benefits. The constraining material only needs to be added once. The plants in the soilized desert enjoy higher yield and biomass, but lower amount of irrigation than those in the nearby natural soil. Highly heat-tolerant plants, such as Artemisia annua and Astragalus absurgens, can grow well without artificial irrigation. The desert soilization proposition is an outcome of interdisciplinary research integrating mechanics, materials, soil, biology, and ecology. With adequate assessment of environment and water resources, the desert and desertified land with access to water can be soilized to control sand, restore the ecosystem, and optimize the land use conditions. With the application of desert soilization on a large scale in the future, the long-standing dream of making deserts bloom will be no longer far away.